Hello, this is Mr. Jones. Today we're going to be doing the notes for Unit 1, Lesson 1, Geometry Basics. Now this is how you're probably going to be doing notes for the rest of the year, so you need to get used to this. If you have any questions about this, please ask me tomorrow morning when you come into class. So Unit 1, Lesson 1, Geometry Basics. So the following are today's objectives. Number 1, you will understand what definitions, theorems, and postulates are and why they are important in geometry. Now these must be in your spiral notebook. They will be graded, so you need to be taking these notes, not just watching the video. You could pause the video if I'm going too fast. That's one of the benefits of the way we're going to be doing notes this year, is that you could go at your own pace. Number 2, you will be able to define, identify, and show the appropriate notation for points, lines, line segments, rays, opposite rays, and planes. So again, pause the video anytime you need to if I'm going too fast. You can rewind if you didn't get something that I said. Definitions, theorems, and postulates are the building blocks for geometry. With very few exceptions, every step of a proof is justified using one of these three things, either definitions, theorems, or postulates. Okay, definition. A definition defines or explains what a term means. Theorem and postulate. Both theorems and postulates are statements of geometrical truth. The difference between a postulate and a theorem is that postulates are assumed to be true, so we just instinctively know it's true. And a theorem must be proven. Pythagorean theorem, it had to be proved based on other postulates or already proven theorems. So again, a postulate is assumed to be true. A theorem needs to be proven true. I'm probably not going to be too picky about this, about you knowing the difference on test questions. But a lot of times students do ask. As long as you're able to prove your proof, then we'll be fine. So I'm never going to ask you to give me the difference between a postulate and a theorem. But we will be talking about them, and often students do ask me what is the difference. So now you have this in your notes. A postulate is assumed to be true. A theorem must be proven true. And then, of course, you know definitions. You have a dictionary most likely on your computer or in a book form. So a definition defines or explains a term. Undefined terms. So some terms have no definition. We really can't define them, so we just have to describe them the best we can. So they're kind of undefined terms technically, and that's not really important either. When if I ask you to define it, you just give me the description of it. I'm not going to try to trick you and count you wrong because you gave me a definition of it. But it is, just for you to know, it is an undefined term, and the first one is a point. So a point is an exact location in space with undefined shape and size. So it really has no length, width, or height. So we really can't define it because it really doesn't even exist. It's just a location. It's an exact location of, you go back to Algebra 1, when you were plotting points on the coordinate plane, you might have said it started out x is 5, it ended out x is 5. Well, 5 minus 5 is 0. It has no size. We have to represent it with a dot because we can never really see a point. A point has no size. Now what's underlined here is what I would say are the important aspects of a point. These things are crucial for quiz questions, test questions. First, if you leave any of these out, your answer will be wrong. It is an exact location in space. So whenever I say to define a point, that's non-negotiable. Now you could use another word that means the same as exact. You could use a precise location in space. I'll take that. That will be correct. But it has to say, now just a location in space, no. Our school has a location in space, but it's big. It's infinite. It takes up a big location. It's not a point. A point is an exact location, a precise location. That is very important. Anytime I ask you this on a quiz or a test, if you do not have exact or precise or another word that has the same meaning as those, location in space, it will be wrong. So you need to have that. With undefined shape and size, I'll take, if you say no dimensions, 0 dimensions, that's also critical. No length, width, or height is another way of saying 0 dimensions. So if you have that instead of 0 dimensions, no length, width, or height, I'll take that. You're telling me that you know there's no size to it. So 0 dimensions means no length, because length is 1 dimension. We have 3 dimensions in geometry: length, width, and height. It has none of those. So that is our way of describing a point. And the things that are underlined are important elements you need, or attributes you need to put in your definition, or else it will be counted wrong. So you need to study that. All right, so here I have a 3D, simulated 3D graph. It has the X and Y, which is your red and green there. Then it also has a Z, which is height, your blue. So a point is located in space. So it does have all 3 dimensions as far as its location. I could say go up 3, or that looks about up 2.5. Go over to -6 for X, and then Y looks like it's -1 or -2, so it's hard to see exactly where it'd be, but it has an X, Y, Z location. Well, in this class, we're mainly going to be working with just 2 dimensions, length and width. So you'll just have to know the X and Y, and it'll be a little bit clearer, but I wanted to point out to you that a point is in space. So it's a location in space. It has 3 elements to its location: length, width, and height. But the point itself has no size. All right, so how do we name a point? This is really important. When you see a point, you're going to name it with a capital letter. So in this case, it's point A. So sometimes we'll have several points. We'll have point A, point B, point C. We just use a capital letter. So if I see a capital letter by itself on your answer, that will tell me it's a point. Or you could just write out the word point A. So point A or A, either of those will be acceptable. All right, so that's how we name a point. So we have a couple more. So we're going to use all uppercase or capital letters. Like I said, capital A or point A. So uppercase means capital letters. They mean the same thing. It's not a or. It's just telling you those are the same thing. Okay, another undefined term is our line. So a lot of times we talk about line paper. You see lines on a football field. Well, those aren't really lines in geometry. We still have to use those representations, but a line has no width. You cannot see a line in geometry. We have to represent it with the type of line we see in our common language. We talk about, like I said, lines on a paper, football field. But a line has no width, no height. It's only one direction. It's only one dimension. It extends in 2 directions forever. So it keeps going on forever, but only in 1 dimension. It goes just the length. The length increases in both directions. The width never increases, the height never increases, but the length increases. It is usually represented by a straight line with 2 arrowheads to indicate the lines extend without end. In this course, lines are always straight lines. So here is an example of how I would represent a line. So I did include 2 points because we'll also learn that line always goes through 2 points. At least it was a lot more points, but we always could use 2 points. There's infinite points on that line, and we'll talk about that later, but we know it goes. We draw 2 points, a line goes through those 2 points. So again, the important attributes to this is that it extends in 2 directions and it's in 1 dimension, or you could say no length, no height. Naming a line. So here we have a line and it has 2 points, point A and B. So one way we can name that line is just with the, like if you look over here, you see my cursor, hopefully you can see my cursor. You have line L or AB with the symbol over it, the line symbol over it. So AB with the line symbol, so you use 2 points, and I can use either direction. I can say point line BA. Line BA is the same exact as line AB. So I could actually just write it out, or at the very end of the line you have a lowercase l here. So you could write it with a lowercase l. This L refers to the whole line. But then there are also 2 points on this line, and I can use those 2 points to name the line. So line L or line AB. If I put a 3rd point on here, I can use any 2 points. Never use 3 points. It will be counted wrong if you use 3 points. You can't say line ABC or line ACB. You only can use 2 points. So line AB is one correct answer. Line BC is another correct answer. Line AC is a 3rd correct answer. And you could even switch the order. I could say line CA, line CB, line BA. The order does not matter. And then we can still name it with the name given to the line. At the end of the line, we have L. Or actually, it's not the end of the line because the line goes forever, but the representation of that line ends at the arrowhead, right? This arrow means it goes forever in that direction, and this arrow means it goes forever in that direction. Use lowercase letters when not using 2 points. So here is the L. It's a lowercase l. So I know that sometimes we could get mixed up between lowercase and uppercase with certain letters. So just make sure you put it away from any points so you don't get it mixed up, so I can't get it confused with a point. Have it at the end of the line and you shouldn't have any problems. Okay, our 3rd and final undefined term is a plane. So a plane is a flat surface that extends infinitely in all directions. Now, all directions means within its 2 dimensions. It has no height, so it's not going to extend up or down. The length extends forever, the width extends forever. So it has no height. So again, the key attributes, when I ask you this on a quiz question, you need to tell me it's a flat surface. You need to tell me that it extends infinitely, and you need to tell me that it has only 2 dimensions, or you can just tell me it has no height, and I'll know that you know it has the other 2 dimensions. It is defined by 3 points, and we'll get to that later. The points need to be collinear. Non-collinear, sorry, they need to be non-collinear. I'm going to talk about that a little bit later. We haven't defined that yet, so you probably don't know too much what that is right now, but we'll get to that a little bit later. So here is a plane, and we have the arrows to show us that it's extending forever in 2 directions, well, 2 dimensions. The length and width are extending forever. So this plane would be like if you had a flat piece of paper that would go through our entire solar system and keep going forever. That is a plane. Actually, our solar system is on a pretty much a flat plane with little exceptions. Naming a plane. So we need to name a plane using 3 letters. We use points, right? So we're going to use 3 points, R, S, and T. So I could say RST, and that will tell me it's the plane, or we could say plane V. So that's a cursive V, and again, you can get that cursive confused with lowercase or uppercase. So just make sure it's not near anything. So we can name this by saying plane RST or plane V, and use cursive letters when not using the 3 non-collinear points. And here's my illustration. If I have line PT, now this V does become very hard. Is this a lowercase v or is it an uppercase V? So if I had this line here, do not put the V there. Put the V up here. Put it away from anything that you can get it confused with. Now I wouldn't have a really hard time deciding whether this V is referring to the line or is it referring to the plane. Now if I had the V over here or take away that line, now I know the V is referring to this whole plane. It's plane V. So be careful when you draw something to keep your letters away from other things that it might get confused with. If you are ever confused, so if I go back to that line, if I do accidentally give you something, oh, I'm not sure if it's going backwards, but if I have that line back here and you had a question as whether the V referred to the plane or the line, then just ask me and I will gladly clarify that for you. I'll clarify that information so you can ask those questions. Okay, so I'm going to pause the video here and give you time to answer these questions. So I want you to describe a point, line, and plane. Be sure to include their important attributes. Try to do this without your notes, but if you need to go back and look into your notes, go ahead and do that. And make sure you study this for tomorrow. So when you're done answering this question, the video will continue. So we'll go from there. All right. Defined terms. So now we're going to get into our defined terms. Segment or line segment. So a segment, or you can call it a line segment. When I say those, I'm saying the same thing. All right. Either if I say in class a segment, or if I say a line segment, I'm referring to the same thing. It is part of a line. It has 2 endpoints, and it can be measured. A line cannot be measured. A line goes forever, right? You cannot measure infinitely something that goes on forever. But a line segment has 2 endpoints, so I can measure from this point to that point, and I can find the length of the line. Remember, that's the only dimension a line has is length. So we can measure the length of a line. So again, what's important about this, if I ask you this on a quiz, it's part of a line with 2 endpoints, and it can be measured. So all of this is important for the definition of a line segment. Naming a segment. So we pretty much do it the same way we do with a line, except there are no arrows on our symbol over here. Remember, on a line we'll have the arrows. That's how you can tell that this is a segment. There are no arrows, so this is a segment. If I had arrows, I'd be referring to the whole line, that it goes infinitely in both directions. Alright, so that's that. Defined terms. Number 2, array. So array is part of a line having only 1 endpoint. It continues infinitely in only one direction. So it's, if you think about a flashlight, you shine a flashlight and the light goes in one direction. So that's a good illustration of array maybe. So there are some differences though. Remember, a line has no thickness, so array has no thickness because this is part of a line. So here is array. It starts at this point and it goes forever through this point, and that's our array. So that's how we would draw the symbol of array. Name an array. Now this is really important. This is a little bit more difficult than the line or the segment was, so you need to listen carefully. So name an array. So I have 2 points, A, B, And we need to always use points when naming an array. I can't name it with a small letter. That would not work. We need to use our points. So here's the correct way of naming this. So this tells me that there's no arrowhead on this side. So this is the start. The start is at A, and it goes forever through B. So it starts at A, goes forever through B. So this one we cannot reverse. So remember on the line I said you can reverse it and call it line BA. This is not array BA. That's a completely different array, and I'll show you that in a little bit. So this is the only one way you could name this. One way and one way only, A, B. So let's talk about some common wrong ways of naming this. Array BA. Well, again, I said that was wrong because that would mean that it starts at B and it goes forever through A. So that's what I'm going to show you here. BA, we start at B, we go forever through A. So B is the origin. It's where it starts. The array starts at B, so B over here. Well, in our original array, the array starts at A. It originates at A and it goes through B. So this is the only correct name. This is not correct. So not correct for this one up here. This one would be referring to that, which is not our question. It's not our illustration. So incorrect. All right. Another way I see students sometimes commonly get this wrong is they'll put the arrow going the other way, saying it starts at A, so there's no arrow here, so that's the origin, and it goes through B. Well, this kind of has some strong points to it, but the notation's wrong. You just can't write a symbol like a letter C backwards. You can't write a question mark backwards. We have certain ways of writing our symbols, and the symbol for array always points to the right. That's just the right way of doing it. So if I saw this, I'd kind of understand what you're talking about, but it's not the correct math notation. I think of math notation as English grammar. There are certain things that maybe you understand, like the word ant. I'm not sure if that's a word anymore, but when I was in high school, they would say ant isn't a word, so you can't use ant in a formal sentence. Well, this is not formal math notation, so you cannot use it. So that's incorrect. One and only one way of naming an array. Okay, we're almost done. One last thing I want to bring up. Opposite rays. If C is between A and B, so here we have a line AB, but we have the point C. Well, that can make two opposite rays. So two opposite rays actually make up a line. So this is ray CA. So ray CA, and this one the red one starts at C and goes through B. So CB. So opposite rays, the important thing to remember about that is it makes up a line. So two opposite rays are a full line, but there are two rays going in opposite directions. So they are ray CA, ray CB. They make up the same one line L. So like points, segments, and rays are collinear if they lie on the same line. So yeah, I do want to talk about, we're going to talk about this much more in class tomorrow, but collinear means that points lie on the same line. So in this word collinear, you see co. So co, think about co-worker. Any teacher in here is my co-worker. We work at the same place of business or the same school. So we're co-workers. Co-linear means that line. You also see the word line in there. Co-line, same line. The points are on the same line. And then we're going to talk about coplanar, and that means the points are on the same plane. So remember before we were talking about the plane, those 3 points that we named the plane with, they weren't on the same line. And that's why we were able to use those. If they're on the same line, we couldn't name our plane using those 3 points. We'd have to find another point. All right, so if you have any questions, ask me tomorrow in class, but you do need to study this tonight and be ready in case there is a quiz tomorrow. Usually I'll have a quiz in the beginning of the class going over the basic sections of the notes. So thank you, and I'll see you tomorrow. Bye.